Howdy everyone, we are Group 24 and we want to briefly talk about the paper, the Federated Learning with Fair Worker Selection. Unlike traditional machine learning, which store data centrally, federated learning is more like a distributed system. In here, the server and the clients only exchange updated models, and every worker trains the model locally without sharing data to each other, which can protect the data privacy. And the challenge of federated learning is limited communication resources, since federated learning requires frequent communication between large number of workers with servers. Due to the large number of workers, we need to pick a subset of workers in each training round, and different worker selection yields different accuracy. Then our goal is to guarantee fairness, which means we need to ensure every worker would be selected to train the model at least for a fraction of time. And also we need to ensure efficiency, which means we need to maximize our total utility. Therefore, we can define our problem as MMSMCF. To be briefly, it's just like finding a subset of workers to maximize the utility in multi-round with fairness constraints.
Well, to apply approximation methods which can reduce time complexity, we can reformulate the original problem as a linear programming problem by considering the non-term fairness assumption. The non-term fairness assumption ensures sustainable fairness over multiple rounds, and our goal is to maximize the utility this federated learning system can achieve, while satisfying the fairness requirement. The key of solving this LP-based problem is by introducing a time fraction vector y, which represents the probability of selecting each worker set S. To solve this, we can take fair stage 1 and fair stage 2 approximation methods. In fair stage 1, the algorithm process can be summarized in two steps. Firstly, the fraction vector starts from 0, and by applying the fair continuous greedy algorithm in feasible region PF, we can get the final output vector y1. In the second step, we apply the randomized deprodding method to select the k workers from the total of n workers, with the probability specified by y1. Similarly, fair stage 2 is a variant of fair stage 1, where y0 starts from r rather than 0, and the updating process ensures every intermediate vector yt remains inside the feasible region PF. The achieved average utility of fair stage 2 has a tighter lower bound than fair stage 1.
So the third algorithm is the FairDG algorithm, and unlike the first two algorithms, which were continuous greedy algorithms and focused on long-term fairness, this is a discrete greedy algorithm and it focuses on short-term fairness, and it does so by prioritizing the unsatisfied workers in each round, and um, it generally involves three cases. So it first tries to find out the set of unsatisfied workers, and if the number of unsatisfied workers is less than k, which is the maximum number of workers which we can select in each round, then it simply selects all those and also adds a random worker to the final result. The second case is where the number of unsatisfied workers is greater than k. In that case, it calculates the depth of each worker and sorts them in decreasing order and selects the top k elements. And the third case is where the length is 0, and in that case it just randomly selects any k workers. So the authors also performed some simulations in order to evaluate these three algorithms, and the two key evaluations were the performance and the fairness selections. So for performance, they found out that all three algorithms performed very close to each other, and it was very close to the optimal value. And they also had analyzed the performance of a discrete greedy algorithm, which outperformed the performance of all three algorithms, but it also had a drawback that it always selected the same set of workers in every round, and which actually violated the first fairness constraint. And this is what they wanted to research in this paper, and they found out that all the three algorithms, fair cg1, fair cg2 and fair dg, actually selected different types of workers in every round, and the fairness constraint was followed very close to the optimal value. So that's it from our side.